Radioactivity property exhibited by certain types of matter of emitting energy and subatomic particles spontaneously. It is, in essence, an attribute of individual atomic nuclei. The discovery of radioactivity. In 1896, Henry Becquerel was using naturally fluorescent minerals to study the properties of X-rays, which had been discovered in 1895 by Wilhelm Röntgen. He exposed potassium uranyl sulfate to sunlight and then placed it on photographic plates wrapped in black paper, believing that the uranium absorbed the sun's energy and then emitted it as X-rays. This hypothesis was disapproved in the 26th and 27th of February, when his experiment failed because it was an overcast in Paris. For some reason, Becquerel decided to develop his photographic plates anyway. To his surprise, the images were strong and clear, proving that the uranium emitted radiation without an external source of energy such as the sun. Becquerel had discovered radioactivity. Becquerel used an apparatus to show that the radiation he discovered could not be X-rays. X-rays are neutral and cannot be bent in a magnetic field. The new radiation was bent by the magnetic field, so that the radiation must be charged and different than X-rays. When different radioactive substances were put in the magnetic field, they deflected in different directions or not at all, showing that there were three classes of radioactivity: negative, positive, and electrically neutral. The term radioactivity was actually coined by Marie Curie, who, together with her husband Pierre, began investigating the phenomenon recently discovered by Becquerel. The Curies extracted uranium from ore and, to their surprise, found that the leftover ore showed more activity than pure uranium. They concluded that the ore contained other radioactive elements. This led to the discoveries of the elements polonium and radium. It took 4 more years of processing tons of ore to isolate enough of each element to determine their chemical properties. Ernest Rutherford, who did many experiments studying the properties of radioactive decay, named these alpha, beta, and gamma particles and classified them by their ability to penetrate matter. When the air from the chamber was removed, the alpha source made a spot on the photographic plate. When air was added, the spot disappeared. Thus, only a few centimeters of air were enough to the alpha radiation. Because alpha particles carry more electric charge, are more massive, and move slowly compared to beta and gamma particles, they interact much more easily with matter. Beta particles are much less massive and move faster, but are still electrically charged. A sheet of aluminum 1 meter thick or several meters of air will stop these electrons and positrons. Because gamma rays carry no electric charge, they can penetrate large distances through materials before interacting. Several centimeters of lead or a meter of concrete is needed to stop most gamma rays. Whenever we study or talk about radioactivity, the name Henry Becquerel at once clicks to our minds. He was the discoverer of radioactivity, for which he also won the 1903 Nobel Prize in Physics. Antoine Henry Becquerel was born in Paris on December 15, 1852, a member of a distinguished family of scholars and scientists. His father, Alexander Edmond Becquerel, was a professor of applied physics and had done research of solar radiation and on phosphorescence. He entered the Polytechnic in 1872 and ultimately became a professor in the same Institute of the Applied Physics.
Talking about the invention of radioactivity, Becquerel decided to investigate whether there was any connection between X-rays and naturally occurring phosphorescence. The glow of X-ray emission put Becquerel in mind of the light in his study, although he had not done much active research in the last few years. He had inherited from his father a supply of uranium salts, which phosphoresces when exposed to light. When the cells were placed near to a photographic plate covered with opaque paper, the plate was discovered to be fogged. The phenomenon was found to be common to all the uranium salts studied and was concluded to be property of the uranium atom. Finally, Becquerel showed that the rays emitted by uranium cause gases to ionize and that they differ from X-rays in that they could be deflected by electric or magnetic fields. In this way, his spontaneous discovery of radioactivity took place as, like most physicists, he had a better understanding of the nature of matter that brought him closer to researching this final philosophical goal. Nowadays, it is generally considered that Becquerel discovered radioactivity by chance, but it is truer to say that he was looking for an effect so similar to radioactivity that he must have discovered it sooner or later. And he was so great a scientist that he quickly realized the importance of his evidence. It is also known that Becquerel discovered one type of radioactivity, beta particles, which is due to high-speed electrons leaving the nucleus of the atom. Becquerel also authored detailed studies of the physical properties of cobalt, nickel, and ozone, studied how crystals absorb light, and researched the polarization of light. He is the namesake of the Becquerel, the basic unit of radioactivity used in the International System of Radiation Units, referred to as SI units. From handling radioactivity stones, he developed serious and recurring burns on his skin, which may have been a contributing factor in history. This famous scientist died in 1908 at Kryosik in Britain, and it is still remembered up till now among the outstanding physicists. Born Maria Sklodowska on November 7, 1867 in Warsaw, Poland, Marie Curie became the first woman to win a Nobel Prize and the only woman to win the award in two different fields, physics and chemistry. Curie's efforts with her husband Pierre Curie led to the discovery of polonium and radium, and, after Perry's death, the further development of X-rays. She died on July 4, 1934. Marie and Pierre Curie were dedicated scientists and completely devoted to one another. At first, they worked on separate projects. She was fascinated with the work of Henry Becquerel. Curie took Becquerel's work a few steps further, conducting her own experiments on uranium rays. She discovered that the rays remained constant, no matter the condition or the form of the uranium. The rays, she theorized, came from the element atomic structure. This revolutionary idea created the field of atomic physics, and Curie herself coined the word radioactivity to describe the phenomena. Mary and Pierre had a daughter, Irene, in 1897, but their work didn't slow down. Pierre put aside his own work to help Marie with her exploration of radioactivity. Working with the mineral pitch blende, the pair discovered a new radioactive element in 1898. They named the element polonium. After Marie's native country of Poland, they also detect the presence of another radioactive material in the pitch blende and call that radium. In 1902, the Curies announced that they had produced a decigram of pure radium, demonstrating its existence as a unique chemical element. She died in 1934 of aplastic anemia, probably developed from extended exposure to various radioactive materials, the dangers of which were only really understood long after most of her exposures had occurred. In fact, Her papers and even her cookbook are still highly radioactive, and many are considered unsafe to handle. Stored in shielded boxes and requiring protective equipment to safely review.